In these videos, I'm going to be going over the homework for week 2, chapter 11, I believe it is. And we're going to start out with day 1 here. The first question is number 4 in section review, and number 4 states, what is the SI unit used for measuring electrical charge? If you look on page 311 of your book, down at the bottom on the right, you'll find a section on measuring electrical charge. And a coulomb is the unit that is used. Coulomb is spelled, and it's actually named after a guy. And this is equal to the charge that is equivalent to 6.24 times 10 to the 18 electrons. So the charge that would be present in this number of electrons is equal to 1 coulomb. So that's number 4. Number 5 says, state the law of charges. And the law of charges is on the next page. Basically says that opposite charges attract. Opposite charges attract, and that similar charges, same charges, repel. So that means if you have two charged particles and this one's positive and this one's negative, then the force is going to attract these two to each other. Whereas if you have two positive charges or two negative charges, that these will repel each other. Number 1 on the think side says, how is Coulomb's law of electrical force similar to the law of universal gravitation? Well, first of all, you have to look at the bottom of page 312 on the right, and you'll see that the force is equal to a constant, which in this case is 8.99 times 10 to the 9th, times the first charge times the second charge. And if you use the 8.99 number, these charges are in coulombs. And then it's divided by the distance between the two charges squared. Now, if you look back in your book under Newton's gravitational law, or if you remember it, you remember that the force between two bodies is equal to the Newton's gravitational constant times the mass of the first body times the mass of the second body divided by the distance between the two squared. You can see that the form here, what they want you to notice is that the form, constant times two things divided by the distance squared, is very similar between the two. The last question on this section, and the last question for this day, is two electrically charged objects attract each other with a force of 1 Newton when they are 5 centimeters apart. What would be the force between them when they are 1 centimeter apart? Now there's two ways you can do this. The sort of hard way is to put all the numbers in and calculate with the, put the force in and do a calculation. The easy way is to say that 1 is to 5, which is the two distances, as the force of 1 is to what number? Remembering that here, if this was just a single number, then and not squared, then the distance here would lower or would raise the force by 5 times. If you divide this by 1 instead of 5, then the overall number here would increase by 5 times. However, because it's squared, instead of 5 times, it's going to increase the force by 5 squared, so it's going to be 25 instead of 5. Okay, so moving on to day 2, and day 2 we move to section 11.2 in the section review on page 318, excuse me. And the first question is question 1. And question 1 states, what are the two major ways to transfer charge between two objects. Now, if you look back, the transfer of charge is another word for transfer of charge is called electrical induction. So don't forget, remember, some of you did not do very well in the last quiz because you didn't read the definitions and make sure you understood that. And so make sure you know that induction is the transfer of charge from one body to another. Now, how is charge transferred? Well, if you look at the section, you can see that it says one way to transfer charge is if they touch. So if they touch each other, then charge can be transferred. Now, in the case of touching, what happens is you have a charged object and you have another charged object, or you have an object that's not charged, and if this one has charges, when they come in contact, this transfer occurs from this to this. Now and what they mean by this question is if you want to move charge from this end to this end, then the charge can be conducted through a conducting material. So the second way that charge is transferred is by conduction. So you can transfer charge via touching, and that's called induction, or you can transfer charge through a conducting material, and that's called conduction. The second question, what is the process of diverting unwanted electrical charge directly into the earth? And this is also on the same section, and the term for that is grounding. So unwanted charge is sent into the earth, and the process when that happens is called grounding. The third question, what is the method of charge transfer? What method of charge transfer produces electrical charges at a distance? Now, this is what they mean by at a distance. That is, you have a charged and you have another charged, and because this has charges, this is affected. The electrons here are affected, and the electrons will come here. And so at a distance, you can have charge be induced. And so this is another way of induction. And then the last one says, what is an electroscope? Well, an electroscope is pictured on page 317. And the purpose of an electroscope is that it's a simple device that's used to detect small electrical charges. So if you look at the picture of the electroscope on page 317, what you see is that there are two very small leaves. And when you bring a charged material close to that top part, it causes the electrons to move away from it because the charged material is negative, and the top part, or the knob there, is positive. And because it's positive, the electrons move down into the leaves, and since both leaves are negatively charged, they are repellent to each other and they separate. And this tells you that they are charged. The top picture on the same page in the same column is a very crude, what's called a Gilbert visorium, which points in the direction of a charge. The third day, we moved to section 3, which is on page 324. So page 324. We do 1 through 6. The first one says, what is the most common type of electrostatic generator in use today? The most common type, if you turn to page 319, you'll see a picture of one. It's called a Van de Graaff generator. The Van de Graaff generator is used to generate electrical charge. The number 2 says, what is the name for the upward flow of positive charge that forms the brilliant flash of lightning? If you look on same page, you'll see the description and the flash of lightning on the car that's in that picture. That return is called a return stroke. Number 3, what is the purpose of a lightning rod? If you turn to page 312 in the second column, you'll see 321 in the second column. By the way, the description of the return stroke is on page 320 in the second column. You'll see that the purpose of a lightning rod is to protect people from lightning. In other words, the lightning strikes the rod and then is immediately grounded as opposed to causing damage. The next question, what device is considered an early type of a capacitor? A capacitor is a device that stores electrical charge. And in the old days, electrical charges were stored in tubes, which if you get a very old television or a very old radio, when I say old, I'm talking about 60s or 70s, then you'll find tubes inside there, and the purpose of those tubes is to store charge. Now, the original, oldest, is pictured on page 323 at the bottom. It's called a Leyden jar. It works on the same principle, it's just much more cumbersome. Now, the capacitors that we use are all solid and not tubes, because tubes can break. And we use solid capacitors which store charge. What is the general term for the devices that store charge? That's a capacitor. How does a photographer use static electricity to make a photocopier use static electricity? The description of this is on page 324, and it's called xerography. Xerography is using static electricity to make pictures or to draw pictures or to write text. And so that's what xerography is. In the next part, we will go over the answers to the handout.